Hey everyone, welcome back to Sir Math's channel, where math meets adventure. In today's video, we'll explore how to take derivatives of trigonometric functions, one of the coolest parts of calculus. So grab your notebook and let's get started. Okay, so let's begin. First, let's start with the sine function. The derivative of sine of u is equals cos of u times the derivative of u with respect to x. This means the slope of the sine curve at any point is equal to the value of the cosine at the same point. Let's have an example. Example, differentiate y equals sine of 3x² plus 2. To get a derivative, we simply make use of the formula. So if we have a sine function here, given sine function, then the answer should be a cosine, and we just copy the given angle here, which is our u. So our u here is 3x² plus 2. So that's why here we have cosine of 3x² plus 2. But don't forget, we have here the derivative of u with respect to x. So we get the derivative of 3x² plus 2, which is our angle, or the input in this case. So we use power rule. So please review the derivative of x to the power of n. So using power rule. And then we have a constant here, so we'll use constant rule. So we have times 3 times 2, then just have x to the power of 2 minus 1 according to power rule, then plus the derivative of 2 here is 0 because it's a constant. Derivative of constant is 0. So we simplify. We have cosine of 3x² plus 2 times, so 3 times 2, x to the power of 2 minus 1 is 6x. Then of course we disregard 0. And then be careful, do not multiply 6x to 3x² plus 2 because this is an input value, an angle in this scenario. So we just rewrite this one. We put 6x at the leftmost part, and hence the final answer is 6x cosine of 3x² plus 2. Let's proceed to the next formula. We have the derivative of cosine function. So the derivative of cosine u is just negative sine u times the derivative of u with respect to x. Notice the negative sign here. This makes sense if you look at the graphs. The cosine slope flips compared to sine. Let's have an example. Differentiate y equals cosine of 4x plus 3. So just like in the derivative of sine function, we simply use the formula. So for cosine, it becomes negative sine. So we have negative sine for x plus 3, and then get the derivative of 4x plus 3. So derivative of 4x is just 4, and then derivative of 3 is 0. So we have 4 plus 0, which is simply 4. And then rewrite. Again, be careful, do not multiply this to the angle because this is not an angle, this is the angle. This is an input value, this is not. So we have negative 4 sine of 4x plus 3, and this is the final answer. Let's go to the next formula. We have derivative of tangent function. So the derivative of the tangent u is just the secant squared of u times the derivative of u with respect to x. Just remember, this is only valid where tangent is defined. Avoid the vertical asymptotes. Let's have an example for this. Differentiate y equals tangent of 5x squared. So, we have tangent of 5x squared. this becomes secant squared 5x squared according to the formula. And then don't forget to get the derivative of the angle, the inner function in this scenario. We have 5x squared, so we have 5 times 2, x to the power of 2 minus 1, which is just 10x. And then we rewrite just like the previous examples. So for the final answer, we have 10x secant squared times 5x squared. Let's proceed to the next. We have the derivative of cotangent function. So for the derivative of cotangent function, we have cot u. Derivative of cot u is just negative of cosecant squared u times the derivative of u with respect to x. So if you try to observe, this is very similar to the derivative of tangent, but instead of having a positive value, we have now a negative cosecant squared. So remember, tangent, derivative of tangent is positive secant squared. So for cotangent, it's negative cosecant squared. Example, differentiate y equals cotangent of 3x cubed minus 2x plus 1. So we will have negative cosecant squared, and then just copy u. Our u here is 3x cubed minus 2x plus 1. And then get the derivative of 3x cubed, which is, so 3 times 3. So we have x to the power of 3 minus 1, and then minus derivative of 2x is just minus 2 times, of course, the derivative of x is 1, plus the derivative of 1, which is a constant, is 0. So if we simplify this further, we will have negative cosecant squared 3x cubed minus 2x plus 1 times the quantity of, so 3 times 3 is 9, and then we have x to the power of 3 minus 1 is x squared minus 2 times 1 is just 2. And of course, disregard 0. And similar to the previous examples, we rewrite this one. Take note, we have a negative sign here, so we will distribute the negative sign in negative 9x squared and also negative 2. So that's why the final answer is negative 9x squared plus 2 quantity times cosecant squared times cosecant squared 3x cubed minus 2x plus 1. So this is the final answer. Let's have the next formula. We are now in the derivative of secant function. So the derivative of secant, so derivative of secant u is just secant u times tangent u times the derivative of u with respect to x. You'll notice that secant's derivative uses both secant and tangent, a common pairing in trigonometry. Example, differentiate y equals secant of 7x to the power of 4. So we just have the formula, use the formula. So we will have secant of 7x to the power of 4, but take note, there is tangent again here, so we will also write tangent of 7x to the power 4, and then we multiply the derivative of 7x to the power 4. So we have 7 times 4 x to the power of 4 minus 1. Simplifying this further will give us secant 7x to the power of 4 times tangent of 7x to the power 4 times, so 7 times 4 is 28, and then we have x to the power 4 minus 1, which is just x to the power of 3. So rearranging this, we will get 28x cubed times secant 7x to the power 4 times tangent of 7x to the power of 4. And this is the final answer. Let's have the last formula. So for the last, we have, of course, the derivative of cosecant. Observe that there are this is very similar to the derivative of secant. So we have a pairing again. So the derivative of cosecant u is just negative cosecant u cotangent u times the derivative of u with respect to x. Example, differentiate y equals cosecant of 6x to the power of 7. So this gives us negative cosecant 6x to the power of 7 times cotangent 6x to the power of 7 times, of course, the derivative of 6x to the power of 7, which is just 6 times 7 x to the power of 7 minus 1. Simplifying this will give us negative cosecant 6x to the power of 7 cotangent 6x to the power of 7 times 42x to the power of 6. So we just rearrange. So for the final answer, we have negative 42x to the power of 6 cosecant 6x to the power of 7 cotangent 6x to the power of 7. Okay, so let's summarize the key derivatives. So we have the derivative of sine u, which is just cos u times the derivative of u with respect to x. So just take note that they are all with respect to x, because our functions is just using x as our variable, but it can have any other variable, input variable. So for cosine u, we have negative sine u times derivative of u with respect to x. For tangent u, we have secant² u times derivative of u with respect to x. For cotangent u, we have negative cosecant² u times derivative of u with respect to x. For secant u, we have secant u tangent u times derivative of u with respect to x. And lastly, we have cosecant u, which is just negative cosecant u cotangent u times derivative of u with respect to x. So take note, the functions that starts with c, so just to memorize it easier for you when to use negative or not. If it starts with c, like cosine u, cotangent u, and cosecant u, they are all in negative. So that could be a pattern for you to memorize the formulas. So these are fundamental tools in calculus, especially when working with chain rule, product rule, or solving real-world problems. That's it for today's video on derivatives of trigonometric functions. I hope it made things clearer and a little more fun. If you found this helpful, don't forget to like, subscribe, and hit the bell icon so you can never miss an episode of Sir Matt's lectures. So if you have questions, drop them in the comments. I'm happy to help. Take note, there will be more examples for this in the future videos. Until next time, keep calculating. Bye-bye!